Okay. Okay, so let's more or less get started. Okay, so let's get started first. All right, so we will start with, as usual, question 2. I presume all of you have done your tutorials already. Okay, so question 2. Suppose we want to know whether the smoking population, whether the smoking population is 5% of the total population. So we conduct a survey and find that 3.5% are smokers. So a student actually carry out this chi-square test. Now hypothesis is the proportion of smokers is 5%. Alternate hypothesis is not 5%. Okay. Find a chi-square statistic of 0.0474. Okay. Therefore, it's actually cannot reject the null hypothesis. The degrees of freedom of 1. Now, okay. So Benjamin, so what has gone wrong?
The student used like percentages instead of like
Okay. And the student use speak a bit louder. The student use percentages, correct?
yeah, instead of like actual numbers are like
Actual
the
numbers. Okay.
frequency,
So
the frequency.
yeah, so that's the wrong part. Okay. Here, the student used percentage instead of the frequency. Okay. This is actually the most common error for chi-square statistic. Okay. You cannot use frequency or ratio. You cannot use percentage or ratio. You have to use the actual frequency. So Ben, do you know why?
No, not too sure.
Not too sure. Okay, so actually I made a video on that already, so you should go and take a look. Now let's see, let me just get to my Excel. Okay. Let us do some chi-square in Excel and I'll show you why you can't do that. Okay. Okay. Okay, suppose we have a hypothesis. Okay, our null hypothesis is the number of tea drinkers equals to coffee drinkers in this group. Okay, so alternate hypothesis is the number of tea drinkers is not equals to the number of coffee drinkers. So this is our now an alternate hypothesis. Okay, what happened to this guy here? Continue, don't bother with it. Okay. So what I have is I have tea drinkers and coffee drinkers. Okay. So let's say that when we do the survey, okay, so our survey results is that we have 51% tea drinkers versus 49% coffee drinkers. So far, any problem, Sean? Any problem? Ben?
No.
Okay. So let us do this case number 1. So case 1, we survey 100 people, 100 participants. So 100 participants, this is almost like using percentage. So we have the expected, oops, wait a minute. So we have the expected and the observed. Okay, so in this case, expected because based on our hypothesis, we should expect 50-50. Okay, but the observed, we have 51 over 49. Now, if you look at chi-square statistic, how is it being calculated is you have the category, your expected, and your observed. Okay. So the chi-square statistic is the summation of your observed minus expected square divided by expected. Okay, so what happens in this equation is the degrees of freedom. In this case, what is the degrees of freedom calculated? Anyone can help?
So the degree of freedom is 1.
No. What is the equation for degrees of freedom in this generic case?
So the formula used should be n minus 1 multiplied by m minus 1, sir.
N minus 1 multiplied by n minus 1.
N minus 1.
This is for contingency table. It's not for this. So what happened is if I have, let's say, instead of coffee, tea, Milo, whatever. Okay, so let's say this. What is my degrees of freedom here?
3 minus 1 equals 2, sir.
Yeah, correct. So in this case, the degrees of freedom is actually the number of categories minus 1. Okay. So now Ben again. Okay, what is in this whole equation, do you have sample size?
As in, like,
Do you have the actual sample? Let's say the coffee, the tea drinker, Milo drinker, and coffee drinker add up to expected you have 105. Do you have any of this sample size inside here, inside the equation? You know, when you do your ANOVA, when you do your t-test, always there's this sample size n. But where is n in this equation? Or it just disappeared?
I'm not too sure.
So do you think it disappeared? Or you just never see it at the moment?
You just never see it at the moment.
Let's never see it, okay? So somehow this sample size kind of disappeared. Okay? Which actually makes chi-square very simple to do. Because even your degrees of freedom in your t-statistic, your t-test, your ANOVA, your degrees of freedom deals with sample size. But in chi-square, your degrees of freedom doesn't deal with sample size. It vanishes. Instead, it deals with, here it is almost like treatment minus 1. Correct? It feels like treatment minus 1 here, if you put it back into your ANOVA. So, but I will tell you that sample size is actually built into this equation, just that you never realize it. And you realize that chi-square is a very simple equation. is so much simpler than your T statistic. So let's look at what happened. So in this case, it's almost like percentage. So we look at the p-value. Okay, so p-value, if you use Excel to do chi-square, it's just using chi-square test. Okay, so actual range is observed. Expected range. Now I get a p-value of 0.8. So in this case, do I reject or accept null hypothesis? Ben. I always Ben today for this question.
Yeah, so p-value is more than significance.
So you accept or reject null hypothesis, the conclusion. Come on, Ben, you can do it.
Accept the null hypothesis.
So you accept null hypothesis. Okay, accept now. So this is the case of you're almost using percentage because you only 500. So let us do this situation, but let's say if you're very energetic and you do a survey of 1,000 people. In that case, your expected is still 500. It's 500. 500. But what will be the observed now? Instead of 51 becomes what number? Based on this probabilities.
510.
510, right? So 510, 490. So let us do the p-value again. Our chi-square statistic. Actual range. You find that the p-value actually drops. Okay, it goes from 0.84 to 0.52. So the number, the frequency actually affects, but not the percentage. So in this case, you will still accept null hypothesis anyway. How about let's do a case, let's say you are even more energetic and you do 10,000 participants. You survey 10,000 people. So you survey 10,000, here will be 5,000, 5,000. And what will be this number here?
5,100.
5,100, right? 5,100. So here we 4,900. And we do your chi-square test for this. Actual range, 5,100. Now, do you accept or reject null hypothesis?
Yeah.
Yeah means?
Or reject.
Yeah, so you reject null hypothesis. Okay, so the sample size does makes a difference. If you use percentage, you will just end up in this one case. Because this is, say this is case 2. So case 3, if you use percentage, there is no case 2 and case 3, it's only case 1. But when you use frequency, there are different cases. And you can end up rejecting your null hypothesis. This is why I say that sample size is actually built into the equation without you knowing it. Okay? So never use proportion. If you really use proportion, because proportion total is 1, right? Let's just do for the sake of doing. We settle one that is case 0. And we use proportion. So proportion total is 1. Okay, so here will be 0.5, 0.5. This will be 0.51. This will be 0.49. This is by proportion. Case 0 is proportion. Case 1 is percentage. Case 2 and case 3, they are actual frequencies. Okay, unless you only survey 100 people lah, then okay. Okay, actual range. See, even these two numbers are different. So use proportion is even worse. Percentage, still okay, but never do it and if you have more than 100, unless you're exactly 100. Okay, so these two are. So sample size is actually a big problem in your chi-square statistic because it is hidden. You realize that the critical value for all of them is the same because it is degrees of freedom, which is all of them have all of them have the same degrees of freedom too. So your critical value is still the same, 0.841. Right? But you realize that the chi-square is different, giving you different p-values. That is why you cannot use percentage. You have to use the frequency. Okay, so hopefully this covers why. So understand why now, Ben?
Yes, thank
Yeah,
you.
explain, huh?
Yeah.
Okay, good. Okay, so next one we have food survey. People were asked about the type of drinks that they eat after a spicy food. Okay. It was found that 47 of the people who surveyed drank water, and so on and so forth. Okay. Now, if you have 200, so these are the people who surveyed. So at 5% significance level, found that okay, the Indian. Okay, so it was this one survey. Okay, Indian restaurant, Indonesian restaurant, want to find out whether is the survey by the company is similar to its customers. So what you have to do is just to fill up these two columns. So Ding, why not you help us fill up these two columns?
So the observed is 91 from 91, then 35.
91, 35, continue.
19,
Uh-huh.
21,
Yes.
13, 11, 10.
11, 10. Then expected column?
It's 86, 38.
Okay, 86, 30 what? 38. Okay,
And 30, 14, 14, 12, 6.
14, 14, 12, 6. Okay, so what is your chi-square?
Wait for which one?
This one, this one. Yeah, this one. It's a final number.
It's I got 10.9.
10.9. 10.8. Yeah, correct. Okay. So in this case, what is your null hypothesis?
No hypothesis is all your probability.
This one, correct. So this is actually the hypothesis. Okay. So the alternate hypothesis. How are you going to write the alternate hypothesis?
I'm not very sure.
Again, can't hear you.
That one I'm not very sure.
Okay. So in this case, all you need to do is you just say that the alternate hypothesis is proportion or proportion different from null hypothesis. Okay, that's all. Okay. What is the degrees of freedom here? What's the degrees of freedom?
Sorry. It's 7 minus 1.
6. Yeah, 6. Okay. And what is your damn stupid with this thing. What is your critical value?
Critical value is is it 12.6?
Yeah, correct. Okay, honor. A critical value is 12.6. Okay, because actually critical value is your 0.05 and degrees of freedom 6. Okay. So do you accept or reject your null hypothesis?
You reject.
Why you reject?
Um,
Is this number larger than this number?
oh, so you accept.
Yeah. Okay, so you fail to reject hypothesis, okay, which means that you accept hypothesis. Okay, so yeah. Okay, then what is the conclusion? If you accept null hypothesis, what does it mean?
I think my conclusion's wrong.
Of course, the conclusion is wrong lah, because this part is wrong ma.
Yeah.
So if now I give you the correct one, how are you going to explain your conclusion?
There's insufficient evidence to show that alternate is true at 5% significance level.
No, you just explain what does this null hypothesis means, lor.
Oh, the Indonesian customers' choices tally with the results.
Lor. So you just say that the Indonesian restaurant customer choices is not significantly different from the survey by the company or national fury food. Okay, so just write that. All right. Okay, so we have the next one for our cross-pollination. Now, this is exactly what you will do when you do your genetics, the Mendelian genetics. It's warm in my room already, so let me go on my stupid noisy fan first. Okay, hopefully my fan is not making too much noise. It is getting very cranky. Okay, Ihan.
Oh yeah.
Yeah. Okay. Okay, so yes. So what is the null hypothesis?
The null hypothesis would be that the findings support Mendel's theory.
How do you write null hypothesis again?
The findings support Mendel's theory.
So you have to write out lah. You have to write out the null hypothesis is that the yellow to green peas is 3:1. Have you done genetics already?
Yeah.
Okay, so you should know how to do your calculation, right? Okay, so alternate hypothesis.
The alternate is that the yellow to green piece is not 3:1.
No. So yellow to green piece is not equals to 3:1. Okay. Now in this case, what is your degrees of freedom?
Will it be 1?
Yeah, lor. Okay, degrees of freedom is 1 because 2 categories now. Okay, so now based on this, what will be your expected and just say I need this for these two columns.
For OI it will be, for yellow it's 498.
Okay,
And then for green is 152.
Okay.
And expected for yellow is 487.5. And then for green is 162.5.
Okay. So what is the chi-square statistic?
The chi-square will be 0.90.
Okay. What is your degrees? What is your critical value here?
Critical value will be 3.841.
0.51. Yeah, 3.841. Okay. So then, do you accept or reject null hypothesis?
We accept null hypothesis.
Hello. So what does it mean?
This means that the yellow to green piece is 3:1.
Okay, so it's a bit different. What you need to say is, it means that the ratio of yellow to green, yeah, piece is 3:1. Okay, yeah. Okay, so that makes your life easier. So this is what we do in your genetics all the time. Okay, when you do your Mendelian genetics. How many of you have done the actual experiment of counting the corn kernels and pea? Do you do that in your genetics class? Or it's just what do you do in your genetics practical? Do you actually ask you count corns?
No, no, sir. Like during our genetics practical, which is somewhat like molecular biology, we are asked to extract like DNA, sir.
DNA. Okay, so you can actually when I learned genetics, corn, different colors. When I did genetics, this is what we are kind of given. All these different color of corn, and we have to count the corn kernels. So that's actually what Mendelian genetics is talking about. You have all those different corn kernels, and then you start counting them. It's quite tedious experiment actually, because you're counting a few hundred of them, and then you just score the colors. Okay. Okay, so let's go to the next question about Gordon Ramsay. Okay, Grace. So what will be the null hypothesis? Grace, are you there? Hello? Hello, can't hear you, Grace. Okay. So what is null hypothesis?
Okay, hear me.
Yeah, I can hear you already.
The null hypothesis is there are equal number. Not equal numbers, equal preferences.
Yeah. Okay.
For
so
the dishes.
Equal preference for the 4 dishes. Okay. Alternate hypothesis?
There is no equal like preferences.
Yeah, lor. So you say difference.
Unequal.
Yeah. Degrees of freedom?
4 minus 1 is 3.
3, correct. Okay, hold on. Degrees of freedom is 3. Then your critical value?
The full value is 7.815.
7.815. Okay, good. Okay, so same thing, fill up these two sets of numbers. So the observed is what?
The first one will be 20,
Next one?
then 21,
Uh-huh.
19,
Uh-huh.
and 20.
Okay. Expected leh?
20, everything.
Okay, or 20.
Okay.
How about your chi-square value? Its final value here.
0.1.
0.1, correct. Okay. So do you accept or reject the null hypothesis?
We fail to reject, so
Yeah.
we accept.
Yeah, fail to reject null hypothesis. You accept null hypothesis. So what does it mean?
There is an equal preferences for the four dishes.
Yeah, equal preference for is for dishes. Okay, that's it. Okay, so you find that chi-square is actually quite easy to do. Okay, let's do the last question. Last question is actually very tough. Now, last question actually deals with when the sample size are actually too low. Okay, then you have to do this thing known as your Fischer exact test. When sample size is too low, you have to use Fischer exact test. Okay, so the problem with Fischer exact test is this. Normally, if the sample size is really this low, unless you do not have a choice, I will ask you to collect more samples. Unless you don't have a choice, we ask you to collect more samples. Because if you look at your tutorial or you at the lecture for Fischer exact test, it's not easy to calculate. Okay. What you have to do is to calculate every single probability, and then you find out what is the observed probability, and then you score all those that is below that. All those that is below the, or rather all those that's above the probability. So in this case, these are the probabilities. So based on this situation, okay, let me just see. Okay, based on this, which one is the probability that you calculate from here? Okay, so which are the three that you add up?
So it should be the one with the 2149. The third.
2149.
Sorry,
So
sir.
this one, the p-value, you add up which three p-values?
The 0.26791, sir.
26791. Okay, so basically you add up these three p-values. Okay, so you get a total p-value of observed equals to 0.5179, and that you reject the null. You do not reject null hypothesis because this is okay. So because the observed is more than your critical value of 0.05, therefore you fail to reject your null hypothesis. Okay, that's the argument, that's the reasoning. Okay, so basically that is all that we have to do for your chi-square test, because the chi-square test is actually very simple. Okay. you will learn to like this guy called Carl Pearson, which came out with chi-square test. Okay. So chi-square test, remember, is categorical. You have to use the frequency rather than the proportions. Okay, so that's all for today. Any questions? Oh yeah, make sure before you start, make sure that if you have any issues, please ask. Yesterday when I was marking your online test too, I'm wondering, do you actually understand your regression or not? Based on some of the results, some of the reply that or answers that you give. Okay, so please take note. Okay, Sean, what do you want to say?
So may I ask, with regard to question 3 about the types of drinks question. So when we are calculating for the expected frequencies, so may I ask, how do we obtain 86, 38, 30, 14?
Okay, so see, these are the probabilities, but you survey 200 customers. So you multiply that by 200 because these are 100 based on 100. So you multiply each one by 2 So 2 times 83, 43 gives you 86 and 2 times 19 gives you 38. 2 times 15 gives you 30 and so on.
And so from the 2 times 19, where we get 38%, we take the 38% multiplied by 200.
We got 38%.
Yeah.
19 is percentage. So you are talking about 19% of 200 people is how many people?
That is 38 people.
That's what you have here. You're scaling up only because percentage is 100%, but now you have 200, so you have to scale based on the numbers. Okay. Now, which is back to the corn counting problem, right? In your experiment, if you actually do this, remember your Mendelian genetics is 9331. So you have to count 1,600 corn kernels. Because 9 plus 3 plus 3 plus 1 is 16. So in order to get a nice number, you count 1,600. Okay, continue, Sean.
And so, similarly, concerning question 5, when we are calculating for the frequencies, we employ the same method we did for question 3 to calculate for the expected frequencies, which are 20, 20.
Because you survey 80 So here, you have 80 in total. The expected you need to be 80. One thing I forgot to say, your expected number and total number, your expected and observed number have to be the same. Because 80 equal proportion, equal frequency, you have to just multiply, calculate it back. Okay.
Yes, sir. So also concerning the writing of the null and alternative hypotheses, if we take question 6, for example, talking about smoking, so can we write smoking does not affect the risk of giving birth to infants with low birth weight? Or must we write it out in the specific format of like having infants with low birth?
Actually, if you write it in English, make sure the English makes sense. That is the more important part. Don't be so convoluted until your English doesn't make sense, which sometimes happened to you before. You can write so much that you start not to make sense already. Okay, so use simple language. Make sure that you understand what you are talking about. Don't convolute your sentence so much that it's hard to read. Okay. So based on that, I would just want to explain to you a little bit more. If you actually do this, okay, so let's say you have 4 categories here, 1, 2, 3, 4, and so on. Okay, so dish, and then we say that this is the wall dish, this is the Wellington. Hopefully you know what is Wellington. It's actually very nice to eat. Just that these days I don't take beef anymore, so this is the fish. Okay, this is the lamb shank. Lamb shank is also very delicious. Okay, so this is the expected. This is the this is observed. This is expected. Okay. Now, if I mess it up and I say that this is 20, 21, 19, and 18. Is it 18? Yeah, 20. Okay. So if I mess it up, so this total 80, right? If I never calculate in proportion, so all this is 20, I instead calculate in by percentage 100, and I say 25, 25, 25, 25, right? It will still give me a chi-square value because the equation still works. Okay, but it still give you a totally wrong answer. Make sure, because here will be observed minus expected will be 20 minus 25 square divide by 25 plus 21 minus 25 square divide by 25, 19 minus 25 square divided by 25 plus 20 minus 25 square divided by 25. You realize that the wrong calculation doesn't give you an error. It's functional. So, but this is wrong because the total number is wrong. So please be careful with it. Make sure that you scale proportionally. Okay?
Yes, sir.
All right. Any other problems?
No, sir. Those are all the questions
The rest? All right. If there is no other questions, now you can go and view your lecture in 10, I think, based my half an hour video on lecture 10. So before I go, for other, I'm going to show off again. So how many of you still do not know my website? Anyone still do not know my website? I haven't given to you before. Okay, I'm just going to put in the chat. Where am I? Don't use this, the other computer. So this is my website. Okay, go to mauricelink.github.io, which I put on the class chat already. Okay, where the hell am I? Okay, then you go to these videos on YouTube. I will show you a lot of different statistics, different videos on how do you use, the first one, like calculate odds and risk ratio, ANOVA and all this. This is the one. Okay, use frequency only for chi-square. Okay, then you will actually see why do I only use that. Okay. This is your lecture. Your lecture is also here. That's all. Nothing very much. Okay. So that's all for today. Have fun. Bye-bye. Yeah, you can go off now. There's nothing else. Okay. Go and have your breakfast. And goodbye. See you next week.